This video is just an extra video in case you were more interested in the number sets. So this is something that we talked about in our Unit 0 video with the real numbers. So all of these things end up being real numbers. So we have the natural numbers, the whole numbers, the integers, the rational numbers, the irrational numbers, and the reals. And these are things that we kind of have already addressed. Um, this is another way of kind of seeing these things on a number line. So the red indicates where these things actually exist on the number line. So natural numbers start at 1, and you can tell there are gaps there. So there are gaps between each of the natural numbers. Everything between 1 and 2 that is a real number is not included in the natural numbers. Okay, so there are gaps in between those types of things. And obviously it continues on. So we could have 4, 5, and so on all the way across. Integers are likewise extending this line, basically mirroring the natural number line going backwards. So the integers are um, all of -1, -2, -3, 1, 2, 3, and so on. And it does include 0. Okay, so 0 is included in the integers. Now, rational numbers start to include fractions. So this actually is a little bit of a misnomer because there are way more rational numbers than you can see here. Um, there are actually an infinite number of rational numbers between 0 and 1. And if that's a little complicated to think about, just think about all of the ways you can write fractions with 1 in the numerator. I would never run out, and all of those are between 0 and 1. So 1/8 is really close to 0. 1/100th is even closer to 0. 1/1,000,000th is even closer to 0. And so the gaps that show up in this picture of the rational numbers are not nearly as big as you might think. Okay. So there are the gaps aren't very big, so to speak, but there are small gaps. And in between those rational numbers are irrational numbers. So, and remember, there are actually more irrational numbers than rational numbers. We talked about that in the Unit 0 video. But that doesn't mean, and this is kind of mind blowing in a sense, but um, between every two rational numbers, there is an irrational number. And between every two irrational numbers, there's a rational number. It's really kind of mind blowing if you stop and think about it. And then you think that there are more irrationals than rationals, and it just kind of makes your head spin. But that's because these numbers are so dense that it's very hard for us to think about. Like if I kept zooming in on this number line really, really close, really, really close, really, really close, I'd still see infinite numbers of rational and irrational numbers in there. Okay, so rational numbers are just all of the fractions that have integers in the numerator and denominator. And obviously, I was listing all of these things, but there are tons of those numbers like 2/3, 2/5, 2/7. Those are also between 0 and 1. And 3/4, 3/5, 3/7, and so on. All of those are between 0 and 1. So we have a whole lot of numbers that are between 0 and 1 that are just rational. Now, the next thing are going to be called algebraic numbers. We have not talked about those. There's a difference. There's one more distinction that we haven't talked about for real numbers, and that's between algebraic and transcendental. So algebraic numbers include the square roots. So these are the rationals and roots. So square roots, cube roots, those are all things that we'll talk about more later in the year. But rationals and roots are included in algebraic numbers. Basically, the way that you can think about this is if you have a polynomial, so for example, x squared minus 2, if you can solve that polynomial equation as long as all of the coefficients are integers. So I know I'm using a lot of big vocabulary here, but coefficients are the numbers in front of the variable terms. Um, as long as you can solve that and all of the uh, coefficients of the variables are integers, then you get what is called an algebraic number. So in this problem, x equals plus or minus the square root of 2. When you solve the problem, that is called an algebraic number. If I had x squared minus 4, for example, I get x equals plus or minus the square root of 4, which is plus or minus 2. Those are algebraic numbers. Algebraic numbers are any numbers that can solve uh, polynomials with integer coefficients. So if I had x cubed plus x squared equals 0, that's a polynomial. I'm picking really simple polynomials. I can factor out an x squared. I get x, oops, I'm sorry, x plus 1. So x equals 0, x equals -1 are answers to that. Those are algebraic numbers. Transcendental numbers are all other real numbers. So e and pi are basically the only two that we really know that like we think about that are transcendental numbers. There are, once again, I know we start making distinctions. There are way more transcendental numbers than there are algebraic numbers. But that is, so we don't really think about those very often. And then finally, filling in all of the other numbers to make the continuous line. So again, algebraic numbers, the gaps aren't nearly as big as you see in this number line, but it's just there to show that there are some gaps in there. And then when you fill it in with all of the transcendental numbers, you end up with real numbers. Now notice that algebraic numbers may include some irrational numbers. So when I look at this, I see that's an irrational number. Uh, So that's something to keep in mind. Now, here is a bigger picture, and some of this we won't touch on ever, and others of it we'll touch on a little bit later in the year. But we also have what are called imaginary numbers. So, imaginary numbers, that's this over here. Imaginary numbers are anything in this oval, and imaginary numbers are any type of value of square root where the square or cube root, or I'm sorry, square root, fourth root, sixth root, any kind of root with a negative number on the inside of the uh, even numbered root. So, for example, the square root of -1, we're going to call that I, and that's something that we won't really touch on until Unit 3. But that is what is called an imaginary number, and so we're going to expand our number system just a little bit. And complex numbers are the big picture, what happens when you include real numbers and imaginary numbers all together. So this is just a very general picture of what actually happens. Um, Notice that there are some irrational numbers over here, but you can also have like irrational imaginaries and other things like that over here. So this picture kind of encompasses everything, and it's probably more complicated than most of you want to get into. Um, but this picture can kind of help you visualize what the number sets look like. And uh, for example, everything works as like layers of an onion, so to speak. So, for example, zeros just kind of chilling over here. Um, but it's exclusive of these other things. It's exclusive of the naturals. But the for example, the rationals include everything that's going on over here. And so the rationals kind of encompass this. But then when you see the imaginary part over here, um, there's a ton of things that go up above that are not included as we go to the right, um, and so on. Now, complex includes the entire circle. Okay, hopefully you're not too confused. The final picture that I want to show you is that when you expand on what's going on in math, so to speak, the number, the graphical system that you have used ever since you started algebra, where you have an x coordinate and a y coordinate, um, that actually can be expanded to talk about the real and imaginary part of the complex numbers. So, for example, if I wanted to look at the point 1 comma 2, I can actually write the point, the visual point 1 comma 2 can be written as the complex number 1 plus 2i. And if I wanted to put a visual value on the complex number 1 plus 2i, I would write a point at 1 comma 2. So this kind of expands and blows up the real and imaginary numbers, and the complex numbers, so to speak, uh, to make it more visual and be able to help you see things. And this is stuff that if you're going into engineering, you obviously don't need to know now, but this is stuff that you will definitely have to know as an engineer if that is something that you want to do, because engineering uses um, complex numbers all the time in order to help solve problems.